Pest and Predator podcast is brought to you by Field Heroes, powered by the Western Grains Research Foundation. Whether you're a farmer, researcher, or educator, visit fieldheroes.ca to learn how beneficial insects can work for you. Welcome to another episode of the Pest and Predator podcast here on RealAgriculture.com, powered by WGRF. When do pests really impact yield? Today we're going to hear from Associate Professor Dr. Shaun Prager and PhD student Teresa Aguiar-Cordero from the University of Saskatchewan. I'm your host, Shaun Haney of RealAgriculture, and we're going to share some new pulse crop research that explores when pests like Lygus bugs actually cause economic damage. We're going to learn how pest thresholds, natural enemies, and improved scouting methods support better timed integrated pest management decisions. And where does technology fit in, allowing us to not only understand the interaction of pests and beneficials, but also tackle the problem as well. So let's bring in Dr. Prager and Teresa Aguiar-Cordero, both from the University of Saskatchewan, to join us. Okay, let's get going here with the Pest and Predator podcast. I guess, Teresa, let's start off with you. What is the main pest management challenge that lentil growers are dealing with right now on the Western Canadian prairies?
Well, I think that depends in the thing is that pest pressure in lentils is highly unpredictable because different insect pests respond very different in the weather and the environment. So, for example, in 2020, grasshoppers were one of the most important pests in lentils. But in recent years, the numbers have been so low. Actually, I was struggling last summer to find enough grasshoppers for experiments. And in the case of aphids, now they are, their population is very high. And during 23, 24, 25, Lygus bugs also starting drawing more attention in lentil crops. So I think that grasshoppers, Lygus, aphids, but it depends in the year, the weather, etc.
Yeah, and Shaun, that kind of speaks to the point that we got to just be on our toes, right? Because based on the conditions and those kind of variables, we may be dealing with all of them, none of them, different levels of them. We got to be really ready for anything.
Exactly. So even in the time that I've been thinking about pests that eat lentils, what I would have been concerned about, what growers would have told me that they were bothered by would have changed over the course of years, between years and among years, right? So yeah, so what's a problem one year isn't a problem in another, usually driven by which is the one that we're trying to fix.
Yeah. So Teresa, let's hone in on those pests that you mentioned. We got Lygus bugs, we got aphids, we got grasshoppers. They differ. How do they differ in the way that they damage the lentils, and why does that matter when we're trying to set some of those economic thresholds?
They damage lentils in very different ways. So, for example, Lygus and aphids both have piercing suck in most parts, but the effect in the plant is very different. Because in the case of Lygus, they piercing and sucking the plant and they inject the saliva, and their saliva have enzymes that macerate the plant tissue. So the impact depends first in the crop stage. So in flowering stage, Lygus can cause flower abortion, and during the podding stage, Lygus can damage very young seeds or even leave these kind of chalk pot or Lygus bites on the developed seeds. In the case of aphids, they even if they also feed by piercing and sucking, the damage is different, more indirect, and they cause plant vigor over time. And the important part here is that they can transmit diseases. With grasshoppers, they are completely different because they have chewing mouth parts. So you can saw the damage very visible, in defoliation. So these are just differences in feeding behavior, but they are also very different in how the weather affects them, as we just mentioned. So for me, it's kind of a puzzle that we need to complete to understand a realistic scenario, and then like yeah, make decisions of how we can manage them.
Yeah. Shaun, yeah.
Yeah, no, I think Teresa's exactly right. Each of them is a problem. Each of them a problem is in some times. And over the last I don't know, decade, we've been working to try to build the tools for some of those things. But each one is its own problem historically, and some of them weren't problems even a few years ago.
Hmm. So, so Shaun, when we look at economic thresholds, like what we can calculate that based on a bunch of research that people
Mm.
like yourselves have been doing. But what, like for the farmer on the ground, what does that actually mean in real life?
I guess there's two ways to think of that. What does it mean? If you think about it relative to your farmer, right? Your goal is to maximize your profit, really, right? We think about yield, but really what you want to do is you want to maximize profit, right? You want to make the most money that you can out of your crop. And obviously, the most money comes from having the most crop you can sell for the most money, right? For the highest price per bushel or acre or whatever it is. Having said that, there's inputs, right? And so you also have some amount of money that you need to spend to do that. I mean, we always think about it as fertilizer, but it's the insecticides and the pesticides that we spray as well, right? What you want to ultimately do is minimize the amount of input, right, and maximize the amount of output. And the economic thresholds, when it comes down to it, are just a way of giving a more sensible number, right? Something that you can kind of get your head around that should, if you follow it, minimize the number of times you have to apply an insecticide, um, such that you're only really using it when you're actually going to sustain a decrease in yield that's going to cost you money, right? So basically, it lets you have a number that you can pinpoint to say, this is when I'm going to start losing money at a greater rate than the cost of what it's going to cost me to fix this problem.
So Teresa, so adding on top, like let's in
Mhm.
that context, what happens when Lygus, aphids, and grasshoppers, in kind of a worst case scenario, they all show up together? What happens there?
You walk down
Well,
the
they are,
elevator.
Sorry, so what
yeah,
was
they are.
sorry, Shaun, what was that?
Well, it's like Dorothy, right? It's grasshoppers, aphids, and Lygus, oh my.
Yeah, yeah. Sorry, go ahead, Teresa.
Yeah, they are all together. And at the same time, we also have other insects that could be pollinators, that could be predators, parasitoids. So for me, like in the PhD, I'm trying to get a kind of a dynamic threshold, like to understand how the presence of other insects can help in the yield. Like for example, if a lentil crop it's at flowering stage, then you need pollinators. So applying pesticide at the wrong time can affect the yield more than the damage caused by the pest itself, maybe. So it's important to understand how factors like not only environmental factors, temperature, humidity, but also how the natural enemies and the seasonality can influence thresholds.
Um, so how could thinking about multiple pests together maybe change the way we make management decisions in the field, then, Teresa?
So one of the experiments that I'm running, it's with drone images. So for example, I survey my microplots, recording all the insects, like the good bugs and the bad bugs, twice a week. And at the same thing, taking images by the drone. So my idea is to correlate, for example, the canopy, like all the different indices that we can get from the drone images with the insect population over the time. So this will help us to understand how different pests stress the crop and how that translates into yield loss. So instead of asking, do I have enough aphids or lygus or grasshoppers to take action? I would like to start thinking or asking, what is the total stress on the crop right now? So
Hmm.
maybe like spray is not necessary.
Yeah. So thinking it like you call it the dynamic threshold, right? Is that how you put that?
Yeah.
Yeah. So not looking at the pests in isolation, but looking at them in totality in terms of what is the actual stress or pressure on the crop given those total population levels at that time. Am I summarizing that correctly?
Yes, yes, and maybe to make the pest management much more integrate,
Mm.
like and realistic.
Yeah, and where did like there's natural enemies are often kind of overlooked in this integrated pest management program, as as you just alluded to. So I guess why do you think predators should be treated as a core part of this IPM
I think
at this
it's
time?
fair
So
that
go
they're
ahead, Shaun.
sorry. I think it's not fair to say they're overlooked. That's not entirely true. They're just, but it's much more difficult to quantify their effect.
Okay.
Yeah.
Um, and so historically, you assume they existed, but you didn't directly factor them in. Right. So you assumed, say, the number of insects you had in your field was somehow being altered by them, but in a kind of a mysterious way. It was kind of a
Okay.
black box, right?
Yeah.
And the result of that is you can't fine tune things. And the numbers themselves are dynamic, right? So the numbers of the good bugs you had aren't consistent over the course of the season any more so than the pests are. Um, and so what Teresa is really trying to get her head around is ways to account for that.
Yeah.
Well, right. And that allows you to fine tune that number more, to take out that kind of unknown factor.
So, Sean, I'm curious. Like, so when we consider those beneficials in the canopy there, okay,
Mhm.
making sure we're considering them. How confident are we that they are going to aggressively do what we think they should be doing in terms of like, being that beneficial that has that, taking care of the insects that they're preying on. Do we have that confidence?
No, that's
Okay.
that's that's really why, in many ways, it is difficult to quantify. That is the trick, and so that is, in a lot of ways, the major task for Teresa is that. Um,
Yeah.
sometimes we do, sometimes we do, but in many cases we don't. And the only way to do that is to do historically would be experiments or just a guess or exclusion. So in the past, we may know because we would have, say, put a cage around a series of plants and then said, okay, well, there's no natural enemies in there. And then how many pests are there? And we can sort of compare them and say, like, well, the ones with the cages didn't actually do as well as the one without the cages, something along those lines. But it's far less common that we knew what was actually being excluded from the cages or the extent to which they're doing that. That is, right, how many things that we don't like are they eating or laying eggs in or killing? Um, and that's what made that a black box. It's why often, and it's difficult and time consuming. That's why people often just kind of ignored it.
Yeah, like we want them to be wolves, not like sloths. Like, we right? It I guess
Yeah.
is there like I, is there things that we can do? I guess these are just things wrapping or kind of bouncing around in my simple brain is are there do we know if there's things that we can do to entice them to be like more interested or more aggressive? Like I guess we're still trying to figure that part kind of stuff out too, I guess.
Yep. And it varies by the insect, right? So
Yeah. Okay. Well, very interesting. So, Teresa, what do you think is currently missing when it comes to insect monitoring and decision making around IPM when we look at this whole package?
Well, I wouldn't say that it's something completely missing because a lot of great work is already being done in insect monitoring. The challenge that I see, it's more about integration of the information and also in the time. Because as a PhD student, I would like to sample many locations across the prairies, but that's simply not realistic given like the geography and in the fact that experiments are very time intensive too. So another challenge is timing. And in many cases, we only fully understand like how insect affect yield at the end of the season. So after all that data have been analyzed.
Yeah.
And in the case of integration, monitoring data it's also it's like often hard to get in real time. and tools don't always connect pest pressure with natural enemies, with economic threshold, crop stress, etc., into one clear picture. So, yeah, that I think that it's the challenge, like time and integration of information.
Yeah, and this is really important work. And Shaun, I was just thinking about the factors, right? So if we're measuring the impact of some sort of pest in a dairy operation, we're in the parlor, it's inside, it's contained, or a pig barn or a poultry operation. When we're talking about crops, we are outside. So we have different thickness of canopy. We have sunlight, we have cloudy, we have wind, we have no wind, we have cool versus hot, and we have those are just a few of the variables. I'm sure there are way more. Trying to understand how those beneficials and pests interact in all those different situations and combinations and permutations, that is what makes this so difficult. Like, how do you actually measure this?
Oh, that's a good question. In some ways, you measure it the same way as you've always done it, which is by simple experiments. In other ways, we have new tools that allow us to do that. So one of the things that makes what Teresa is doing a little different, or maybe not different, over the last, say, 5, 10 years, the tools that we can use to do some of these kinds of things, to answer some of these questions, um, well, they either exist now and they didn't, or they've come across, right? And on other ways, you do things the same way as you always have, which is a bad answer. So, for decades, people have done some of this, right? You would have taken the thing that you didn't like and the thing that eats the thing you don't like, and you would have sort of, I don't know, put it together in a glass jar or something, and like watch them eat each other, right?
Yeah.
And then you said, okay, one lady beetle eats 15 aphids, and so all right, in X amount of time, and so now we have an estimate, right?
Don't miss
And
on Tyler Wiss doing the play-by-play of all that happening too. So
that
don't
is
miss.
exactly right. Tyler loves that stuff. That is exactly what Tyler does. Yes. So if you had Tyler here, you'd have him doing the right. And that's what Tyler and I would have both grown up, not that we're old, but like even a decade ago when we would have started learning to do things, that's what we would have done. And it's what the people who taught me sort of would have done, right? And that's kind of how you go about it. But this is where technology is sometimes kind of neat. And so Teresa, while she still does some of that, has a whole array of fancier and more expensive methods available to her that allow her to do this in a very different way, including right from the field. And so maybe she should explain what she's doing, but she can employ things, molecular biology tricks that weren't available until recently or too expensive,
Wow.
and remote sensing methods to answer some of these questions in ways that we just couldn't otherwise.
Teresa, tell us more about some of these technologies that we're hearing about here from Shaun.
Sure. So, yeah, actually, technology is like one of the things that excite me a lot yeah, as a tools for pest management. So, for example, in my PhD, I am flying a drone to take pictures and then correlate with the canopy stress and then with the yield and with the presence or absence of the different insect pests and beneficials too, well, natural enemies. And also in the PhD, I'm trying to know exactly what the predators are eating. So for that, I'm running DNA extraction from the gut content of ladybugs, damsel bugs, spiders, to understand what are they really eating. Um, and apart, like alongside my PhD, I also start developing a tool that brings like this threshold and integrate monitoring and ecological context together. So, yeah, in my PhD and outside of my PhD, technology, I think that it's like something that is very excited for me because, I mean, when like in the past, pesticides were the new innovative tools, and today we have apps, drones, AI. So just like insects and agro systems evolve, pest management it's also like constantly evolving. So yeah, using these technologies, I think that can help um, the management of pests to be more integrated, sustainable, practical, and realistic.
Well, and using all those tools, like using all the tools available to us to try to tackle an issue that we know is not going away. We know farmers are challenged with this, and as Shaun mentioned earlier, it comes down to profitability. And there are pests in our canopy that are trying to rob us of yield. They're just every day they're working at trying to chip away at our profitability, and we can't just rely on one way of doing it. We do need to open ourselves up and really look at the full toolbox available to us. So really important research, and I really do appreciate both of you joining us here today for the Pest and Predator podcast.
Thank you very much for
I hope you enjoyed this episode of the Pest and Predator podcast. It's brought to you by Field Heroes, powered by the Western Grains Research Foundation. Visit fieldheroes.ca to learn how beneficial insects can benefit your farm.